Today, as part of our Algebra 1 introduction, we're going to talk about simplifying expressions. First, let's talk about what expressions are. An expression is a mathematical phrase that may contain numbers, variables, and/or operators like addition and subtraction. A variable is a letter that represents an unknown value. Terms and coefficients. Terms are separated by addition and subtraction signs. The coefficient is the value or the number in front of a variable in a term. A term without any variables is known as a constant. So using what we know about these terms up here, let's look at an expression and see if we can identify the terms, variables, coefficients, and constants. So I know terms are separated by addition and subtraction signs. So I know that I have three terms. The first term I see is 5x. The second term I see is positive 17. And the third term I see is negative 11y. Variables are the letters representing an unknown value, and I see I have two variables here, two different letters, x and y. Coefficients are the number or the value in front of a variable. So looking at this example here, I see a coefficient in front of my x, and I see a coefficient in front of my y, that negative 11. So my coefficients are 5 and negative 11. My constant is a term without any variables. So no letters are attached to the number, and the only one I see is 17. Pause the video and do the remaining steps for the second example. Next, we're going to talk about like terms. Like terms have both the same base, where they have the same variable, and the same exponent, or the same power. So looking at this first example, here are my terms. I have negative 3c and 5c squared. Although both terms have c in them, they have different exponents or different powers. So these are unlike terms because they have different exponents. The next one, 1/4 and 20. Both of these are constants, so they are like terms. The next one, 8.5x and 8.5y. They are unlike terms because they have different variables. The next one, 100p and negative p. These are like terms because they have the same variable and the same exponent. So since those two are the same, these are like terms. Next, let's get into simplifying expressions. Expressions do not contain equal signs. Therefore, they cannot be solved. However, expressions can be simplified by combining like terms. Something important to remember, the sign in front goes with the number. So what I like to do whenever I am simplifying expressions is I like to draw lines to separate the different terms. So for example, right here I have x minus 2x minus 3 plus 5. I know that my terms are separated by plus or minus signs. So right here, my x is a term, negative 2x is a term, negative 3 is a term, and plus 5 is a term. Now I'm going to combine my like terms. Now remember, like terms have to have the same variable and the same exponent. So look at my x's first. Do I have any other terms with an x inside of it? I do. This negative 2x. So that means I need to combine x minus 2x to figure out what that is simplified. So if I have x and I'm taking away 2 x's, now I have negative 1x or negative x. Over here, I have two constants I can combine. I have negative 3 plus 5. Well, negative 3 plus 5, I know that when I add these two numbers together, since my signs are different, I'm going to subtract and take the sign of the larger number. So 5 minus 3 is 2. The larger number is 5. 5 is positive, therefore this is going to be x plus 2. And this is my expression simplified. Let's do the same thing for this example here. I know that my terms are separated by addition and subtraction signs. So I'm going to first separate all of my terms. Then I'm going to identify like terms. So I'm going to start with my x's. So I'm going to identify any other term that has an x with the same exponent. So right here I see another x and I do not see any more, so I need to combine those. I have negative x minus 9x. When I combine those two terms, negative x minus 9x, that gets me negative 10x. Then I'm going to do look at my y's. So I have plus 6y, minus 2y, and minus 4y. Well, let's look. I have 6y minus 2y. That gives me 4y. 4y minus 4y is 0. So really, I'm going to add 0, which I don't even need to write down. So it's going to be negative 10x as my simplified expression. On this example, I have two terms. I have 3x squared plus 5x squared. I need to look and see if I can combine any like terms. Well, I see an x squared here, and I also see an x squared here. So both of these they're like terms. So when I combine them, I'm going to be doing 3x squared plus 5x squared. So combined, I have 8x squared. In this last example here, I know my terms are separated by addition and subtraction signs. The sign goes in front. So first thing I see is x squared. Now I'm going to look for any other x squareds. I see one more. So I have 2x squared minus x squared. Well, if I have 2x squared, and I'm taking 1x squared away, I have x squared left over. Next, I'm going to look at my regular x's. I have two terms with an x in there. I have negative x plus 5x. I'm going to use my integer addition rules. My signs are different, So therefore I need to subtract. There's an invisible 1 here. So 5 minus 1 is 4. 5 is the larger number, 5 is positive, so I'm going to add 4x. And then I look and see what's left. I have my constants left. So I have plus 3 minus 2. Well, I have 3 minus 2, which is equal to positive 1. So this is my simplified expression. Now that we have completed some examples, you will work on the remaining examples on your own.